Today we are going to discuss garbage collection in .NET framework. And as part of this session, what we are going to discuss? We are going to discuss what is garbage collection in .NET framework, what is garbage collection in .NET framework. Then we will discuss what are managed and unmanaged objects in .NET framework. Then we will discuss what exactly managed and unmanaged code in .NET framework, right? Then we will discuss what are generation, why do we need generations, what are the different generation of a garbage collection, right? Then I will show you one tool called .NET Memory Profiler. I will show you how to download and install .NET Memory Profiler. Then I will create a simple console application. Then I will run that console application using this tool called .NET Profiler. Then I will show you the different generations which are created for your .NET application using this .NET Profiler tool, right? Then I will show you three different examples, right? One example without using Destructor and a Dispose Pattern. I will show you one example using Destructor, then I will show you how it is bad for performance, right? Then I will rewrite the same example using Dispose Pattern, and I will show you how it can overcome the problem of a Destructor. And with this, we conclude that, we will conclude our session, right? So let us start today's discussion. First of all, what is a garbage collection? See, whenever we are developing any real-time application, right, whether it is a banking application, whether it is a insurance application, whether it is a e-commerce application, right, while we are running our application, lots of objects are created. Lots of objects are created means, suppose you are using Facebook, right? You are using Facebook application. So at the same point of time, millions of users accessing the Facebook application. For each, suppose your class having one object, right? Then if 10,000 users accessing your class, means 10,000 objects are going to be created for each user, right? So one object for one user, 10,000 users means 10,000 objects are going to be created, right? And even though it is also possible that for a single request, right, for a single user, it might be possible that 10 or 50 objects are going to be created internally, right? Then at a given point of time, right, at some point, it is also possible that some of the objects are going to be unused by the application, right? Once you start your application, you created 100 objects. After executing some time of your application, you might be, it's also possible that out of 100, 50 objects are unused, right? Then garbage collector in .NET framework, it is nothing but a small routing, right? Or you can say it's a small background process thread that runs periodically, right? And try to identify what objects are not being used by the application and deallocates the memory of those objects, right? So simply speaking, when you create one application, when you are running that application, you are creating lots of objects. At some point of time, it is also possible that some of the objects are not used by the application anymore. Then garbage collector, which is a part of a .NET framework, actually in .NET framework, when we install two things. What are these? One is CLR and one is BCL. BCL means the class and the libraries which are required to develop your application, and CLR is nothing but a common language runtime, which is your runtime environment where your .NET application is going to run, right? As part of that CLR, there is something called garbage collector. So garbage collector is actually a component of CLR which is going to execute periodically at some at every you can imagine every 5 millisecond interval the garbage collector is going to run every 5 millisecond interval. You can assume like this, right? So each time it run or each time the garbage collector run, then it will try to identify what are the objects that is unused by the applications. You are creating 1,000 objects. Out of 1,000 objects, garbage collector see that 50 are unused by the application anymore. Then what garbage collector will do? He will deallocate the memory for all those 50 objects. So garbage collector, it means it's a small routing, or you can say it's a background process thread which runs periodically, right? So what is garbage collector means? It is a feature provided by CLR which helps us to clean or destroy unused managed objects. Cleaning or destroying those unmanaged objects are basically so if you are saying cleaning or destroying the unused object means basically you are reclaiming the memory. So whatever the memory allocated for that object, it is going to be reclaimed. It is going to be free of the memory, right? The point that you need to remember is garbage collector will destroy only the only the managed objects, right? Garbage collector will only destroy the unused managed object. If the object is a managed object and if that object is not used anymore, then it is going to destroy it. It is not clean the unmanaged object, right? For unmanaged object, what we need to do? Either we need to write the code explicitly using the destructor, or we need to write the code explicitly using a dispose pattern. Both the approach we are going to discuss today also, right? Then the question that comes to your mind is, sir, what exactly the managed and unmanaged objects in .NET framework? Yes or no? So first of all, you guys understand what is garbage collection or what is garbage collector? Guys, you understand what is garbage collector and yeah,
use
how
object, object.
Sorry,
The garbage collector is going to destroy the unused object.
unused managed objects automatically, right?
Yeah, and the unmanaged objects, you have to
Yeah,
use those.
explicitly you need, yeah, for unmanaged object you need to write the code explicit, right? So let's see what are exactly managed and unmanaged object, right? See, whenever you create any exe means if you are developing any console application, Windows application, then one assembly will be generated that is of the type .exe. And if you are developing any web application like you ASP.NET MVC, like ASP.NET Web API, ASP.NET, you can say class library project, right? Then the DLL is going to be generated, right? And whenever you are working with in this type of this kind of applications, then you can use Visual Studio and any of the .NET supported programming languages like C#, VB, and etc. etc. These applications, what you developed like MVC, Web API, class library project, console application, Windows applications, are completely run under the control of CLR. The CLR will be the runtime environment for running these kind of applications, right? So if you are developing any kind of applications using Visual Studio, right, using any .NET supported programming language, then that application is going to be run under the control of CLR. CLR means all the facilities what available for CLR, it will provide and it will manage the applications, right? So that means if your application have unused object, right? Suppose you are creating any ASP.NET MVC application or Web API application or class library or console application or Windows application, then if your application having any unused object, then CLR will clean those objects using garbage collector, right? Then CLR will clean those objects using garbage collector. Now let's say you have also used other third-party exe in your .NET application, like you have include Skype, you have include PowerPlay, you have include Microsoft Excel, right, on your .NET application. Then these exes are not made in .NET, right? So if you are taking Skype or if you are taking Microsoft Excel, so these are third-party applications. You are not developing these applications, but you are using those applications in your .NET application. Let's assume that these applications are developed using some different programming languages like C, C++, Java, etc. Right? So if these applications, Skype, PowerPoint, Microsoft Excel, is developed using C, C++, or Java, right? And these are third-party application for your application, then CLR will not take the responsibility to execute these exes, right? Because these are not .NET applications. You are not developing these applications. These are developed by some other companies, right? And you are just using these applications on your environment, right? For running the .NET application, for running your application, CLR is there. But for running Skype, PowerPoint, and Microsoft Excel, CLR is not there. They are going to be run under their own environment for their own runtime environment. If Skype is developed using C and C++, to run Skype, you need C and C++ runtime environment. You cannot run Skype under .NET runtime environment because CLR will not execute this code, right? So this code or these exes are going to be executed by their own environment. That is the point that you need to remember. As CLR will not execute this thing, then the memory allocation and the memory deallocation is also going to be handled by their own runtime environment or not? Yes. Or no? Right? That means if you are allocating some memory for the Skype exe in your .NET application, then CLR will not going to be destroy those unused objects, right? Because this is not a managed object. As it is not a managed object, CLR will not manage the things, right? These objects are going to be destroyed explicitly by the developer. If you are using Skype and if you are allocating some resources for Skype, then as a developer, it is your responsibility to destroy those objects by writing some code, right? You can write the code, you can write the, you can write the resource release code in two places, right? What are the places? You can write it either inside the destructor or you can implement the dispose pattern, right? And then you need to write the code. So let's see. When you use these exes in your application, then these are not run by CLR. Even though you are running these exe in .NET applications, they are going to run under their own environment, right? For example, if one exe is developed using C and C++, then that exe will run under C and C++ runtime environment only. In the same line, if the exe is created using VB6, then it is going to run under the VB6 runtime environment. Is that clear?
Yes.
Yes.
Yes, sir. Very clear. Thank you.
Now we need to understand what exactly managed and unmanaged code in .NET. We have already discussed. See, the code, if someone asks you what is managed and unmanaged code example, you can give this, right? Then if you need some more clarity, what are the benefits we are getting with managed code and what are the benefits we are not getting with unmanaged code, then you need to tell this one. The code which run under the completely control of CLR are called managed code. These kind of code are run by a .NET runtime environment called CLR. Right? .NET runtime environment called CLR, Common Language Runtime. If the .NET framework is not installed or if the .NET runtime environment is not available, then these kind of codes are not going to be executed, right? Suppose you are developing one exe, right? Using .NET application. Then if you want to run that exe, then what is mandatory, what it requires? .NET runtime environment called CLR. If CLR is not there, then you cannot run that exe. Why? Because CLR is going to take care of whatever resources is required to run the application, right? That will be taken care by CLR, and CLR is not there. Then how you can run the application? You cannot run the application, right? But if you are running the application under the complete control of CLR, then it's said to be a managed code. And if it is a managed code, then CLR will provide all the facilities and features to the .NET managed code execution, like language interpretability, right? Automatic memory management, exception handling mechanism, code access security. We will discuss these things, right? What is language interpretability? What is automatic memory management? What is the exception handling? What is code access security? Once you discuss the .NET framework architecture, if you look at our syllabus, then there is a chapter called the .NET framework, right? In that .NET framework architecture chapter, right? Everything we are going to discuss. What is CLR? What is BCL? What is CTS, right? All these things we are going to discuss. What is language interpretability? What is code access security? Everything we are going to discuss. But these are some of the features which you only get if your code is a managed code. And now we are only focusing on automatic memory management. Automatic memory management in the sense, if you are creating a managed object, then the memory allocation will be done automatically by the garbage collector, right? And the memory allocation will also destroyed automatically by the CLR. CLR means as part of CLR, there is a component called garbage collector. That garbage collector will take the responsibility to destroy the memory automatically. And this is only possible if your code is managed, right? On the other hand, Skype, PowerPoint, Microsoft Excel do not require .NET runtime environment. They run under their own environment. So in short, the EXE or web web application which not run under the control of CLR is unmanaged code. CLR will not provide any facility and features of .NET to the unmanaged code execution. Like all the facilities what we discussed here, you will not get if your code is unmanaged code. Is that clear? Guys?
Yes. Yes.
Okay.
Yes.
Yeah. So,
Yes, sir.
Yeah. So we have discussed that one point. Do you understand that garbage collector is there, which is going to destroy the unmanaged objects, right? Sorry, which is going to destroy the managed objects. And if your code is managed code, then all the facilities what we have discussed, language interoperability, automatic memory management, exception handling, all these features and facilities will get if your code is managed code. Now let us understand how this garbage collection or garbage collector in .NET framework works, right? Right. So to understand how does the garbage collection or garbage collector work in .NET framework, we need to understand the garbage collector generations, and then we'll see how does it affect the and then we'll see how does these generations affect the garbage collection framework. Basically, there are three kinds of generation: generation 0, generation 1, and generation 2. Let's say you have developed one application called app1, right? Suppose you developed one application called app1, and once your application start, as soon as your application start, you created 5 objects, right? 5 object means you created 5 trace objects. The first point that you need to remember is whenever you created any .NET framework any object in your application, right? Then all those objects are going to be created inside the generation 0. So any phrase object, any phrase object you created, those objects are going to be created in the generation 0 only, right? You can see this is your application and this is your generation 0 bucket. As soon as you created 5 objects, all those 5 objects are going to be created inside the generation 0. Now, then what actually our hero Mr. Garbage Collector do? Now it run continuously as a background process thread. We already discussed what is garbage collector. Garbage collector is a small routing, or you can say it's a background process. It run periodically, right? You can consider 5 milliseconds, 10 milliseconds, right? It run every 5 milliseconds. It run every 10 milliseconds, right? To check whether there are any unused object or not. And if there is any unused object, then it reclaims the memory by cleaning those unused objects. So now let's say 2 objects. Now let's say now our application run, our application created 5 objects, and now 2 objects are not needed by the application anymore. Let's say object 1 and object 2, their work is done. They are not needed by any more in our application. And what we do, we just make them as null, right? Then what will happen? Then what will happen in the sense of what will exactly the garbage collector will do is it will destroy those 2 objects from the generation 0, right? It will come, it will periodically run. It will once run, it will come to this generation 0 bucket, and once it comes to generation 0 bucket, it will check is object 1 is ready for garbage collector, is object 2 is ready for garbage collection. Yes, these 2 are ready. Just to destroy the memory, reclaim the memory by destroying these 2 objects. Is object 3, 4, 5 are unused by the application, or they are still used by the application? Yes, they are still used by the application. Then do one more thing. Just move these 3 objects from generation 0 bucket to generation 1 bucket and make this generation 0 bucket as completely available, right? For understanding, you can look at this object. Your application run in previous step, we have created 5 objects in generation 0 buckets. Now From the generation 0 bucket, the garbage collector run and it check 2 objects are not needed by the application anymore. Destroy those objects. So object 1 and object 2 are destroyed, but still object 3, 4, 5 are needed by the application. Then just move those 3 objects from generation 0 bucket to generation 1 bucket. This is what you can see in this application, right? Now let's say again 2 more fresh objects are created in your application. Fresh object means they are going to be created inside the generation 0 bucket only, right? So you can see 2 more fresh object means they are going to be created inside the generation 0 bucket only. Now again garbage collector runs and again it comes to generation 0 bucket and checks which objects are in. Let's say both objects are unused by the application. Then what you will do is you will remove both objects from the generation 0 bucket. Right, after removing the generation 0 bucket, at some point of time the garbage collector will visit to generation 1 bucket, right, and checks whether all the objects are still used by the application or there are any unused object, right? Let's say object 3 is not needed by the application anymore. Then what he will do, he will delete this object 3 from the generation 1 bucket and he will move rest 2 objects from generation 1 to the generation 2 bucket. You can see. So first of all the objects are destroyed from here. Second, it will come to generation 2, right? So from generation 2, it will remove the object 3 and it will move object 4 and 5 to generation 2 bucket. Is that clear? How the garbage collector is going to work? We will discuss why it is moving from generation to generation 1 and from generation 1 to generation 2, why we have different kind of generation, that we will discuss now. But for now, did you guys understand how the garbage collector work and how many generations are there?
Yes, sir.
Okay. Right. Then the question is, sir, what are generations? So generations are nothing but will define how long the objects are staying in the memory. Right? So if you are creating one object in generation 1, if you are creating one object in generation 0, or if you are creating any object in generation 2, that means this generation will decide how long the objects are going to be stay in the memory. The object which are there in generation 0 will basically stay some less amount of time than generation 1, and generation 1 object will stay less amount of time than generation 2. Or the objects which are in generation 2 means they are going to be stay for a longer period of time, right? So the generation means they basically define how long they are going to be stay in the memory, right? Then the question is, why we have 3 different generations? Why we cannot do all this thing in a single generation? Yes or no? Why I'm going to move from generation 0 to 1, from 1 to 2? Why I'm not using this single bucket and store everything here? If required, use it. If not required, then delete it. Yes or no? You should have this question or not? Can anybody
Yes,
tell me?
obviously.
Yeah. Can anybody have any idea why we have 3 different generations? Okay.
I think it refers to the time, like it's how long the objects have been generated at what time instance.
No.
Maybe.
Whenever you create any object, that for sure that object is going to be created inside the generation 0 bucket only, right? And then we are just moving from this to this and this to this. Why we are moving from one generation to another generation?
Time saving.
Maybe easy manageability.
Easy manageability, how you can say? If you are putting all those objects in a single generation, it is easy, na? He is only visiting to this generation, checking whether object is used or not. If used, let it there. If not used, delete it there.
It may be
I
a
think
long
how-
list of objects, long list of objects, unused.
No. So let me clarify this, right? So, yeah. So these are 3 generations. If the garbage collector visiting this generation 0 bucket in every 5 milliseconds, then he is going to visit this generation 1 bucket in every 10 milliseconds, and he is going to visit this generation 2 in every 15 milliseconds. That means in 1 hour, the number of times it visit to generation 1 is going to be more than generation 1, right? The number of time it visits to generation 1 is more than the generation 2. That means the less number of time it visits to generation 2, the garbage collector will less visit to generation 2 than 1, and 1 than 0. That means the more number of time it visits to generation 1 and the less number of time it visits to generation 2. And each time it visits to a generation, it will check each object, whether that object is needed by the application or not, right? Suppose you created this object in this generation 0, right? Then every time it visits generation 0 bucket, it will check whether this object is needed or not, is needed or not, is needed or not, yes or no. But if you move this to this or this to this, that means this object is going to be stay a longer period of time in the memory, right? If you are moving this to this one, means it is see, whenever we are going to move from 0 to 1, now if we see that this object is not unused, right, and it is still used by the application, then why should I visit again and again? Why should I check that object again and again? Just move this object from this location to the next location, so that I will visit less number of time and I will check that object less number of time, right? And if still that object is used by the application in generation 1, then he will transfer that object to generation 2, where he will visit less number of time, right? That means the checking process you can consider to whether that object is used by or not is going to be reduced, right? If this object is there in generation 2, in 1 hour, let's assume the garbage collector check this bucket 10 times, then in the same 1 hour, the garbage collector is going to generation 0 100 times, right? Assume that. And 100 times means it is going to check the object are used or not. 100 times checking the object is used or not, it's going to take some time. You understand, man? So 100 times checking and 10 times checking, which is going to take less time, guys?
10 times, obviously, yeah.
Right, 10 times. Then this is the reason why we have 3 different generations, and we are just moving from generation 0 to generation 1 and generation 1 to generation 2. The object which are going to stay a longer period of time will be in generation 2. Then object which is going to stay fewer times in the object are going to be generation 1. The object which are going to be stay less number of time in the memory is going to be generation 0. And you can consider generation 0 means they are going to be created and they done their work and they are just to destroy. And if they are going to stay for some time, then they are going to be moved from generation 0 to 1. Sometimes means there are less number of visits to check whether the object is used or not. If the object is going to stay for a longer period of time, then we are just moving that object from generation 1 to generation 2, right? Now let's understand. When we are working with a big application, they can create thousands of objects. So for each of these objects, if the garbage collector goes and check if they are needed or not, it's really painful and it's a bulky process. By creating such generation, what does it mean? If an object in generation 2 bucket means the garbage collector will do fewer visits to this bucket. The reason is that if an object moves to generation 2, it means it will stay more time in the memory. There is no point going and checking them again and again. So in simple word, we can say that generation 0, 1, 2 will help us to increase the performance of the garbage collection, right? The more the object in generation 0, the better the performance. The more the memory will be utilized in an optimal manner. Why? Because if you are creating some object in generation 0, whatever the memory allocation, they will be deallocated immediately. That means you are utilizing the memory efficiently. But if you are putting the object in generation 1 or generation 2, means they are going to stay for a longer period of time. That means if it is required, then you can put the object in generation 1, right? Then if it is not required, and if you are putting, if you are not destroying the object, right, then it doesn't make sense now. It will allocate some memory, it will reserve some memory for more number of time, right? So always try to make sure that the more number of objects are going to be created in generation 0. Why? Because if you are creating the object in generation 0, right? They will give you better performance. They will utilize the memory efficiently because it will allocate the memory, it will deallocate the memory. Memory is free, na? So you can store other objects. There should not be any memory leakage issue. There should not be any memory shortage, right? But if you are storing some object from in generation 1 or in generation 2, then you are not utilizing the memory efficiently. You will get your performance will be degraded. See, suppose you create one object.
One small question here,
Yeah, ask
if
me.
I can ask.
Yeah, sure.
Yeah. See, these generations, are they created dynamically by the system? Or,
Yes. These are
or
generated
as per the application, as per the needs of the application, there can be n number of generations or
No.
only
There are
predefined.
only three generations. This is the system architecture of CLR, right? The garbage collector is a part of our CLR component, right? The garbage collector is designed in this way, right? So your application is going to be run by the CLR. As part of CLR, there is a component called garbage collector, right? And that garbage collector will basically decide the object is going to be created in which generation, right? So objects are going to be created inside the heap memory only, but garbage collector know in which section of where it is exactly created. I need to put that object in generation 0 or 1 or 2. There's only 3 different generations, no more than 3, right? And based on the utilization of the object, it will decide whether I need to move this object to generation 1 or not. Suppose, for example, okay, let me simply give one idea so that you will get some idea. Okay. Right. Suppose I am creating one program class here. Okay. Okay. Give me, suppose this is some method, public void some method. Right. Some console.writeLine statement. Right. What I'm doing, I'm just creating the program class object. Right. I'm just calling the program.sum method, right? So here I create an instance and I use that instance, right? The use is completed, but then what I'm doing some other things. Console.writeLine, something I'm doing, some additional work. I'm also doing some additional work, right? Then I'm just making this program equals to null. So in this case, the object is created. Object is created means it is created in generation 0 only. So any fresh object, they are going to be created inside the object. Now, see, objects are always going to be created in heap memory, right? But to manage that object, CLR is there, na? CLR will decide at what location. I mean, there is heap memory, no doubt about it. Objects are created in heap memory, but in heap memory, in which which generation they are going to be stored, right? So that the generation, in the sense, you can consider it is also part of your heap memory, and in heap memory, there are 3 different generations which is provided, which is managed by garbage collector, and the garbage collector will decide this object I need to store in generation 0 or in generation 1 or in generation 2. Is that clear?
Yeah, but one question, please. So those generations are like some kind of signal as the frequency that they should be inspected, or is it the physical place in the heap memory? I mean, see the question. I mean, it's just a signal, a mark where you say, okay, we're going to check these objects every any millisecond, every 5 milliseconds, and these others every 10. Is a mark in the object, or is it a physical place in the memory?
See, that is the internal mechanism of a garbage collector. We cannot predict at what time or what interval they are going to check the object, right? They are checking the object means they are only going to check the object in heap memory only. But in heap memory, we might be stored that object in general. See, whenever we are creating, so this is one object creation statement. Whenever we create this object, it will be created inside generation 0 bucket only, right? After using this object, right? So I mean, we are doing some other kind of activities. We are doing some other. So this thing, it's a other statement. I mean, it's a other kind of activities. Again, other kind of activities. Again, other kind of activities. Again, other kind of activity. This is your program execution. It will be continue as it is. But in some time, so again the garbage collector will come to this generation and check, right, whether that object is used anymore or not. Yes, that object is not is used in the sense we are not making that object as null. That means that is a used object. There are some references to that object. So what he will do, he will just move this object to this bucket, right? He will just move this object to this bucket, right? But what you will do, if you do like this, so instead of using like this, if you put that object on that I mean that of program equals to null, that means if you put this statement here, then once the object is used, then we are just making that object as unused. Then it will come to this generation, the garbage collector will come to this generation and we'll see that yes, that object is no more used. Let's remove it, or let's destroy the memory or destroy the object and reclaim the memory. But if you put this statement behind the scene, your application is going to be run as it is, fine, that is fine. But what problem you are facing, that you are facing, you are stored. See, whenever you create this statement, some memory is allocated. You use that functionality. But once you use that functionality, why you wait to destroy this object for this statement to be executed, right? Why I'm going to wait till all these statements are going to be executed? Why I'm going to wait till all these functionalities or all these functions are going to be implemented? I create the object, I use the object, I need to destroy the object. If you are not destroying the object immediately after using the object, then what problem you will going to face? It will move that object from this generation to these generations, right? Once it moves this object from this generation to this generation, it means it is going to stay some longer period of time in the memory, right? Immediately it is visiting, frequently it is visiting to generation 1, but not frequently it is visiting to generation 1, right? So at some point of time, it is making this object as null. But once it is make this object as null, immediately the garbage collector will not visit to this generation, but it is immediately visit to this generation. At some point of time, it is visit to this generation, then it will check whether that object is used or not. Yes, it is not used anymore, then remove it. Is that clear?
Yes.
Yeah, it's okay.
Just one doubt, sir.
Yeah.
Suppose like generation 0, 1, 2, like is there any like you have given example as 5 millisecond, 10 millisecond. So is that the exact time, or it's what is the exact time?
Yeah, we cannot predict any exact time. That is the internal architecture decided by the garbage collector, and garbage collector will do it automatically, right? If garbage collector periodically visits the generation, right? But if he sees that there is a memory problem, right? The RAM is getting filled up frequently, then he will visit more time to this generation 1 and generation 2, right? We cannot predict any exact time of the garbage collection visiting any interval. You cannot predict. We can assume that it's a 5 millisecond, but this is internal. We cannot control this also, right? That is already we cannot control this. So it's internal mechanism. We cannot say exactly at what time interval it is visiting generation 0, at what time interval it is visiting generation 1, and what time interval it is visiting generation 2. We cannot predict.
And can we check whether our current object is in which generation by any
Yes,
means, or it
yeah,
is
yeah. I
totally
will show
hidden?
you. I will show you that
Okay.
practically, right? I will show you that practically, right?
Okay.
So
Thank you.
is that clear? So that means the point that you need to remember is the more number of objects in generation 0 means the better performance. More number of objects in generation 1 and generation 2 means your performance will be degraded. Why? Because it will stay in the memory for a longer period of time, even though they are not used, right? So the point that you need to remember, while you are creating the application, right, you need to properly manage the object. And those who are working with the real-time application, they might know some kind of a using statement we are using, right? So inside the using statement, you can write this object creation statement, right? You can write this like this, right? Yeah, you have not implemented disposal pattern, so you are getting this error. Right, so you will get your error will be gone. So in this case, what will happen now? Once as part of this using block, you are creating an instance. When you are going outside, it will automatically call the dispose method, right? So if you are looking at this code using statement in any of your application means, you will see that you are not calling this dispose method additionally. Internally, when you go out of this close curly braces, it will make invoke to this dispose method. If you are not seeing this code, that is fine, but internally it will invoke this method. But if you want to implement additionally or externally, if it's a unmanaged or some kind of things, then you can write this dispose pattern, right? This is same thing. So what I saw previously using statement and just creating the program, it's same as this statement. Using statement automatically invoke the dispose pattern, dispose method. Is that clear? Right. So you will see that using statement and how we are calling the dispose method, right? We will see coming forward, going further in our course. But for now, you just need to remember in your application, if you are working with any real-time project, and if you are seeing that we are using the using statement, right? Using statement means internally it is invoking the dispose method. Don't be confused that, sir, I have used this resource, but I am not calling this dispose method. But if you are using statement, then internally it is invoking the dispose method, right? So now we'll see one tool called the .NET Memory Profiler. And by using this tool, I will explain you, I will show you the different generation, and I will show you how the destructor is bad for performance and how you can overcome the destructor performance using the dispose pattern. Now I have provided the link. If you visit to this website, .NET Memory Profiler, you can see what it's saying. .NET Memory Profiler is a powerful tool for finding memory leaks and optimizing the memory usage in your program written in C# VB.NET or any .NET language. With the help of this .NET profiling, the automatic memory analyzer and specialist tracker, you can make sure that your program has no memory and resource leaks, and that the memory usage is as optimal as possible. That means it's a tool. And using this tool, you can effectively manage your application. Application in the sense, you can manage how the memory is utilizing, how the memory utilizes by your application code. And you can check whether the memory leakage issue are there, right? How many objects are created in generation 0, how many objects are created in generation 1 and 2. If you are creating more number of objects in generation 1 and 2, that means there is some issue in your code. Then you need to find out how you can resolve those issues, how you can move the objects which are going to be generation 1 and 2 inside generation 0 only, right? We will see all these things in this session, right? First of all, you need to download. So download a free trial, or you can download pricing information. So once you click on this download button, it will download the exe file, right? Once you download the exe file, so you just need to visit the website. The link is provided here, right? Once you visit the website, once you click on this download free trial, this screen will become, right? And here you just need to click on this download button. And once you click on the download button, the exe file will be downloaded, right? Then what you need to do, you just need to click on that downloaded exe file. And once you click on that downloaded exe file, this window is going to be occurred, right? Here, what you need to do, you just need to check the checkbox. That is the select, you need to agree with the terms and conditions provided by .NET Memory Profiler. Once you click on this checkbox and once you check this checkbox, then you just need to click the next button, right? Once you clicked on the next button, then this window will occur. Here you can see what are the different versions of Visual Studio you have installed on your machine. All these will become. In my machine, I have installed 2017, 2019, and 2022. So all these options are available. And you want to use this .NET Memory Profiler on which version of your Visual Studio, you can select the checkboxes, right? If you have installed only 2022, you will get only this checkboxes, right? This checkbox only. You just need to select the checkbox. If you are having 2 versions of a Visual Studio, 3 versions of a Visual Studio, 4 versions of a Visual Studio, you just need to click checkboxes as per your wish on which version of Visual Studio you want to use. Then you need to click on the next button. Give me 1 minute. Right. So once you select the Visual Studio version where you need to integrate or where you need to run the application using .NET Profiler, then you need to click on the next button, right? Once you click on the next button, this screen will appear. It is basically installing screen. So once you click install, then it will ask you, do you want to allow this machine to change, right? You just need to click yes, because we are installing means we are doing something changes on our machine. You just need to click yes, and once you click in yes, then it will start installing, and once the installation completed, you will get this message: installation successfully completed, right? So once the installation successfully completed, your .NET Profiler is installed on your machine, then you can search the .NET Memory Profiler on your search bar, or you can directly so search bar means, suppose I'm writing .NET Memory Profiler, this window will appear. So once you click on that, then one screen will be visible to you, right? Okay. This is nothing but your home screen, you can say, and here it will ask you what you want to do, whether you want to buy the enterprise edition or a operational edition, or you just want to use for a standard edition, right? I'm just using as a standard edition, so it will give you 7 days of a free working, right? 7 days in the sense 7 days, not like you install Monday and it will work till Sunday, right? 7 days means working days in the sense, suppose I am running this application today, then today is 1 day. If I am not running for the next 3 days, it will not count the next 3 days, right? Again, you use on Sunday, that means that day and today. It is going to be 2 days only. Give me 1 minute. Sorry. Yeah. So basically, you just need to go with the standard edition and you just need to click the OK button. Once you click the OK button, this is going to be your this is going to be your screen for .NET Memory Profiler. And using this .NET Profiler, we can run our .NET application. Let's see how we can run the .NET application. First of all, you need to create one console application, right? So once you create the console application, then what I'm doing, okay, I'm copying this code. So this is my console application, right? I have created this console application in my D drive project folder. Okay, so you need to find out where your application is created. So it's a very simple application. I'm having 3 classes: class 1, my class 1, my class 2, and my class 3. And what I'm doing, I'm creating the object of these classes. And how many times? This number of times I'm creating the object. But in this case, you can see I'm not using any kind of a destructor. I'm not using any kind of a dispose method or nothing. I'm not using anything, right? So I'm just creating the objects and that's it, right? Now, if you let us find out the location where this application is created. So this application is created inside the D drive project garbage collection, right? So this is the location where this application is created. So you can identify where you created your application. Once you created the application, then you need to build the solution, right? Build succeeded, you can see in the right. So you need to make sure that your application is built successful, because we are not going to run this application using the start button. How we are going to run the application? We are going to run this application using our .NET Memory Profiler tool, right? So just go to your .NET Memory Profiler window. So there is an option called the profile application, right? Click on that application. Once you click on this application, here you need to provide the executable path. Executable path means your exe file path. So just click on this browse button. Once you click on this browse button, then you need to check where your application is created. So my application is created inside a D project and garbage collection bin debug, and this is my exe. You need to select this exe. Once you select this exe, click on the open button, right? Then you do not need to do anything. You just need to click on the start button. Once you click the start button, then it will run your console application, right? See, your console application is running. Once it runs the console application, then just it will give you the memory architecture, right? How your memory is utilizing, right? To make you understand what I'm, you need to go to this section, right? Manage the memory statistics. You can see here we have 3 generations, right? Generation 0, generation 1, and generation 2. And you can see 11 number of objects are created in generation 0. Is that clear? So as this time, the number of objects, see, you can see, you might have one question, sir, I'm not creating 11, then how it is showing? Sure, it's showing because some objects are deleted automatically. So once you created this object, it is also going to be deleted automatically, right? But it is showing that you are having more number of objects in generation 0, right? Using this tool, you can check the different generation of your application, right? This is the RAM, and inside RAM, this is the heap memory. Inside heap, your objects are going to be created, and inside heap, it will allocate 3 different generations. And now all the objects are created inside the generation 0 only. Is that clear?
Yes.
Okay. Now we will see.
Sir, one,
Yeah, ask me.
sorry. Like when we are creating, suppose inside a loop, for loop, and we are creating 1,000 objects at random pace. So as soon as it created the generation, suppose 1,000 records are getting created, and all those 1,000 records is generation 0 is having capacity to hold all those 1,000 objects.
Yes,
Or
yes.
what is the capacity of those?
See, in this case, once you created these 3 objects, so once you come to this close braces, then these 3 objects are unused, right? You understand my point? Unused means they are no longer used. So once you see, suppose I'm executing this loop for one time. After executing this through loop, once I come outside the loop, can you access these 3 objects? The scope is limited to this scope, right? So once these 3 objects are completed, means you cannot access this object, right? Each time the loop will execute, it will create 3 different objects. Object are going to be, this is your object statement, creation statement, right? The object is going to be created inside the heap memory, and this is nothing but your reference variable, which are going to be created inside the stack memory. So once your loop completed, the stack memory allocation, what is the stack memory? For each loop, for each iteration, the stack memory is going to be clear, right? But the object are not going to be clear. Object are created inside the heap memory, right? This time 3 object, again 3 object, again 3 object, like this, it will create number of objects in the heap memory. And periodically, garbage collector will come and check whether that object is used or unused. If not used, then it will delete that, right? But the thing is that you can create any number of objects inside the generation 1. First of all, when you create an object, if it's a fresh object, then it is going to be created inside the generation 0 only, right? Then depending upon the user, depending upon the use, right? If you are not destroying the object, or if you are not making that object null, right? Then it might be stay for a longer period of time based on your use, right? So, but in this case, all the objects are created inside the generation 0 bucket only, which is good from performance point of view. Is that clear?
Yes, sir. One more thing in the, like, what is the capacity that it can hold? Is there any size, or it depends on the RAM that we purchase on our laptop or machines?
Yes. It's basically depend upon your RAM size, right? So how
Okay.
your RAM
And
size? Yeah.
And if you create a couple of objects outside the loop, what would happen?
Yeah, outside the loop, if you create the object, then also it is going to be created inside the heap map. Suppose I'm creating 3 more objects inside the outside the loop, then also it's fine. This object is also going to be created I mean, this object is also going to be created inside the
But how does it
Zero
show
only.
in the memory?
Yeah, it's going to be created inside the zero of generation zero, right? But in that case, you cannot predict the number of objects in generation zero, right? Because as soon as these applications come to this place, the object is going to be deleted. It might be possible that you will not find any. See, this 11 means you can see the number of objects we have created, but it's showing only 11 because only 11 are currently active, right? Once you create the object in generation zero, then garbage collector will run periodically, right? It will come and check and destroy the object,
Okay.
right? So we cannot predict the number of objects, or we cannot give guarantee the number of objects are there in generation zero, because some of the objects are created, some of them are used, some of them are unused. Unused means the garbage collector will come and delete the object, but we cannot give guarantee when the garbage collector will destroy the object, right? What is the time interval, how frequently it is visiting the generation zero, we cannot predict anything. But one thing we can predict, if you are creating objects, means it is going to be created, if it's a fresh object, it is going to be created inside the generation zero bucket only. But if the object is staying for a longer period of time, then it will move that object to generation one. Even though if you are creating some kind of a destructor, then you will see that how the object are moving from generation zero to generation one, that we will see now. But for now, it's a point that you need to remember, whenever you create an object, it is going to be created inside the generation zero bucket only. And if that object is not needed by the application anymore, then it will delete from the generation zero only. If that object is going to be stay for a longer period of time, then only it will move that object to generation one. Right? Clear?
Clear. Thanks.
Okay. Right. Now in our last session, someone asked me the question, how Destructor is bad for performance. Now let's see. As we already discussed, garbage collector will only clean up the managed code. In other words, for any kind of unmanaged code, as a programmer or developer, we need to tell explicitly the garbage collector to clean up the unmanaged code, right? The garbage collector doesn't have any control over them to clean up the memory automatically. We explicitly need to tell garbage collector for unmanaged code cleanup, right? For example, let's say you have a class called my_bb, my class in bb.net. Then you have to expose some kind of a function. Let's say you have exposed one function cleanup, and that function you write the logic to clean up the unmanaged code. From your .NET code, you simply need to call that method to initiate the cleanup, right? The point or section from where you would like to call the cleanup code is your destructor of a class, right? Suppose you are having one, you are using any third-party libraries, right? And or you are using any unmanaged code, right? And that third-party library or that unmanaged code provides some mechanism, right, to clean up the unmanaged code. And the place where you need to call that function, or how from where you need to clean up the unmanaged code, the place is a destructor, right? The destructor looks be the best place to write the cleanup code, right? But if you write the unmanaged cleanup code inside the inside a destructor, there is a problem. What is the problem? Let us understand. When you define a constructor in your class, the garbage collector, before destroying the object, will go and ask the question to the class, do you have a destructor? If you have a destructor, then move the object to the next generation of objects. In other words, it will not clean up the object having a destructor at the moment itself, even though it is not used. So it will wait for the destructor to run, and then it will go and clean up the object. Because of this, you will find some objects in generation 1 and generation 2. See, to understand this, okay, also let me explain you this thing practically so that you will get better idea. Okay, let clear this session, right? So this is a managed code. See, this is your class, this is your class, and this is your class. You created few objects, right? You created an object. After the execution of this object is useless. This is unused, right? Then before, then when the garbage collector run, then it will ask, this is your object, you know that this object is of my class one. It will ask the class, hey, Mr. Class, Do you have any destructor? Yes, the class having any destructor. Then what he will do? He will not destroy the memory immediately from generation 0 bucket. He will not destroy the memory from generation 0 bucket. Rather, what he will do, he will move the object from generation 0 to generation 1 and let the destructor to destroy the object. You understand my point? If you are writing a destructor in your class, and once the garbage collector run, and garbage collector will come to your generation 0 bucket, and the garbage collector check whether this object is used or unused. Yes, this object is unused. But before destroying the object, it will ask the class, hey, Mr. Class, do you have any destructor? The class will reply, yes or no. If the reply is no, then it will delete the object from the generation 0 bucket only. If the reply is yes, means the class having a constructor. Then the garbage collector will not delete that object immediately, right? Then the garbage collector, what he will do, he will move that object from generation 0 to generation 1. Even though the object is unused, unused means it should be deleted. Instead of deleting the object from generation 0 bucket, what he will do, he will move the object from generation 0 to generation 1 bucket. As we move the object from generation 0 to generation 1, instead then what will the problem? The problem is that object is not going to be deleted immediately. The problem is that unused object is going to stay in the memory for a longer period of time. Yes or no? Guys?
Yes.
Yes.
See, object is unused. Once the object is unused, before destroying the object, the garbage collector will ask the respective class. A class, do you have any destructor? The class will reply, yes, I have a destructor. Then the garbage collector will respect the destructor. Respect the destructor means it will not clean up the object immediately. What he will do? He will move that object from generation 1 to the next generation, and in that next generation, the object will be there. And when the garbage collector of the class is run, then when the destructor of that class is run, then that destructor is going to destroy that object from the generation 1. Right? As we move the unused object, see, moving the unused object from one generation to another generation, does it make any sense?
No.
If you are moving an unused object, if it is a used object, that is well and fine. But if you are moving an unused object from one generation to another generation, then it doesn't make any sense. And why this is possible? Because of the constructor of your application. Because of the destructor of your application. Because of the destructor, the garbage collector moving the one object from one generation to the next generation, right? Let us prove this. So in this case, you can see, even though these objects are unused, and even though our class having the destructor, then you will see that when you run the application, some of the objects are going to be in generation 1, right? Let us run this application and see this practical. Right? I'm starting the application. Okay, I'm running the .NET memory profile and I'm selecting the exe file. Now you will see that. So you can see 73021 1151. You can see or not? 1151. That means some of the object in generation 0, some of the objects are in generation 1, some of the objects are in generation 2 also. That means moving the object from one generation to another generation, and this is possible when we are using destructor. So in this way, destructor is bad for performance. Performance means it's utilizing if you are creating destructor, if your class having destructor, then memory utilization is not that efficiently, right? So destructor you should avoid in your application. Destructor should be act as a backup for your application. What is backup and how to avoid destructor? Now the answer is, the solution is dispose pattern, right? The solution is dispose pattern. First of all, you understand this point, how it is how the objects are moving from generation 0 to generation 1 and generation 1 to generation 2.
Yeah, it's okay.
Yes.
Okay.
Yes.
Now the question is,
So,
yeah, the question is, yeah, ask me.
yeah, I just wanted to ask, like, if the garbage collector explicitly we define, then the destructor garbage collector will not destroy those objects at all, or still
Yeah, garbage
it'll
collector
it'll
will
destroy.
that when the destructor function will execute, at that time, the object are going to be deleted, right? So they,
Okay, until and until how many objects are created, they are not going to destroy it until the destructor
yes,
is
yes.
executed. Is
Right.
it?
Right. So a garbage collector will respect the destructor, right? If you are using destructor means you are doing something additional, and the garbage collector will respect this thing. He will not remove the object immediately. He will move the object from this generation to the next generation, from this generation to the next generation, because garbage collector periodically visit all these generations, right? And whenever the destructor function execute, that destructor will delete the object from either, if that object is generation 0, it will delete from generation 0. If that object in generation 1, it will delete from 1. And if the object is in generation 2, it will delete from generation 2. But if you are using destructor, that means your memory utilization is very poor, right? You are not utilizing the memory properly, right? Your memory utilization is very high. So this is the problem. If you see some of the application which are running on a real-time application, the memory utilization, the CPU utilization is very high. Memory utilization is very high because of this thing, because you are not properly managing your objects, right? So you need to think about it. And when you run your application using this Dotnet profiler tool, he will give you the hint, and he will give you that the number of objects are created in generation 1 and 2. So you need to think how you can reduce this. Then you need to check your code whether I'm using any destructor or not. If you are using destructor, then you need to write some other way. You need to avoid, or you need to think in the other way how you can achieve the same thing without using destructor. And the solution to achieve the same thing without using destructor is dispose pattern, right? So what you need to do, you need to implement iDisposable interface on your class, and you need to provide implementation to the dispose method. And let's see how we can do the same. Already in our previous article, in our previous session, we have discussed the dispose design pattern, right? So I'm just copy pasting the code. Let me copy the code and paste it here.
Uh,
Yeah.
just out of curiosity, like, can we see that, like, if we created around 1,000 objects and we're not calling the garbage collector by default, and we're not executing the destruct method also, can we see those objects created in the generation list? Like
See,
the tool?
if you are creating 100 objects, right? It's not like that 100 objects. See, once you execute this method, and once this statement is completed, once this statement is completed, this object becomes null, right? Once this object becomes null, then the destructor function is going to be executed by the destructor function is going to be executed by the garbage collector only, right? So if you are invoking gc.collect also, it is not executing the destructor. It is just making a request to the garbage collector to execute the destructor, right? Then it is the garbage collector. He is running periodically, right? And he is checking whether the object is used or unused. If it is used, then he will delete the object. But before deleting, he will check whether the class having the destructor or not. If the class having a destructor, then he will move that object from generation from one generation to the next generation, and you will continue its work. Then that destructor, once it move the generation from one generation to next generation, it will call it will say that destructor, hey, destructor, please execute your code, right? He just moved the object from one to next generation, and he will ask the destructor to execute the code, and then the destructor function is going to execute, and then the destructor function is going to delete the object from the memory, right? Is that clear? But
So whenever it changes,
but you cannot see 1,000 objects in the generation 0 or 1 or 2. You cannot see that.
okay.
Because once the object is created, right, that object is not used. That not used means either by garbage collector or by destructor. They are going to be deleted immediately. Right?
Okay, so the time is very less, even though it
Even
changes the
yeah,
I
very,
think
very
you cannot
less.
see them.
You cannot
Okay.
predict the time. The time interval. The time interval is very less. Right? Very
Okay.
frequently they are running and they are deleting the unused object. Right?
Okay.
Yeah.
Thank you.
Yeah, so now you can see this is my class 1, and in this class I have implemented the disposable pattern, right? And in our previous article we have discussed this is one property, and this property is basically used to check whether it is a redundant call to this dispose method or not. If this is a redundant call, then it will not execute this logic, and if it is not a redundant call, then if it is calling for the first time, then this statement is going to be executed. And this pattern, this property will basically decide whether to release the managed object or not. And here you need to write the statement for unmanaged resources, right? And then this is your class destructor. And if your class having one destructor, that means finalizer, destructor and finalizer both are the same, right? And if you are overriding a finalizer, or if your class having a finalizer or destructor, then you need to call this statement gc.surface finalize, and here you need to call this dispose method by passing the value true, right? So, and from your class you just need to call this a dispose method. What I am doing here, I'm creating the object. My object creation completed. I have utilized this object. I just need to call the dispose method as soon as possible, right? Once I call this dispose method, it will call this statement. It will call this statement means this statement is going to be executed, right? Here you need to write the code to release the resources explicitly, right? Once that resources completed explicitly, it will invoke this statement. This statement means it will tell the garbage collector, hey garbage collector, I have cleared the resources, so don't and just ignore the class destructor. Just ignore the destructor. gc.surface finalize means it will ask the garbage collector to ignore the destructor of the class. Don't wait for the destructor. Don't think that this class doesn't have any destructor, and you just do your code as you wish. Suppose, right? Then suppose this object having both managed and unmanaged code, right? And if you are just destroying the unmanaged code, right? And you don't want this class to be this function to be destroy the managed resources. This method should destroy only the unmanaged resources. Then you just need to call this method by passing the value false. So once you pass the value false, then this method is going to destroy only the unmanaged resources. Then for managed resource, how they are going to be deleted? Garbage collector. Garbage collector will come and garbage collector will delete the managed resources. But before deleting the garbage collector, it will not ask this class, right? Why it will not ask? Because we are already telling the garbage collector, please ignore the destructor of the class. But if you are not invoking this method, right? So suppose you forget to call this dispose method. If you forget to call this dispose method, that means this piece of code is never going to be executed, right? If this code is never going to be executed, then we're writing the destructor. The destructor is going to execute, and once the destructor is executed, then we are calling this method by passing false code, right? False means it will call this method and the unmanaged resources are going to be deleted, right? So this destructor is going to act as a backup if you forget to call this dispose method, right? So even though if you are calling this dispose method, then this dispose method will taken care everything. It will going to delete the managed and unmanaged resources. It is going to tell the garbage collector to ignore the destructor. But if you are not calling this method, then it is not telling the garbage collector to ignore the destructor. That means before deleting the managed object, it will ask this class, do you have any it will ask this class, do you have any destructor? This class will reply, yes, I have one destructor. Then it will not delete the code. Instead, it will invoke this destructor, and this destructor is going to delete or destroy the resources, right? But from your code, you just need to call this method, and this method will taken care everything. It will delete the managed resources. It will delete the unmanaged resources. It will tell the garbage collector to ignore the destructor of the class. Is that clear?
Yes.
Yes.
Okay.
Yes, thank you.
And the same thing is I have implemented in class 2 also, right? I'm implementing the dispose method. This is the destructor. This is the dispose method. And in class 3, I'm also doing the same thing. Now from your application, what you need to do, now once you create the object, once you utilize the object, then you need to call the dispose method. In this case, what will happen? Now the object, see, when the garbage collector will move the object from one generation to another generation, when the class having any destructor, yes or no?
Yes.
Right? So suppose suppose this statement is executed, right? After executing this statement, whenever you come outside, so whenever this statement is executed, means it is going to be created inside the generation 1 only. This object is going to be created inside the generation 1. After coming out from this, the garbage collector will see that this memory is unused. Then it will ask the class, do you have any destructor? If yes, it will move the object to the next generation. But now, after executing this object, what we are doing? We are executing this statement now. Once this statement is executed, it will call this method now. Once this statement, it will call this dispose method. This dispose method calling the surface finalize method. And when the surface finalize method is invoked, it will tell the garbage collector, please ignore the destructor of the class, right? Once you tell the garbage collector to ignore the destructor of the class, then garbage collector will not ask the class, do you have any destructor or not? It will not ask. It will know that this class doesn't have any destructor. So it will not move the object from one generation to the next generation, right? When this dispose method is executed, that dispose method will call this version of the, this dispose method will call this dispose method, and this dispose method, which is taking a Boolean type parameter, will taken care of everything. Will delete the managed resources and also delete the unmanaged resources. Now, with this version of code, now if you will run the application, even though your class having destructor, then you will see that all the objects are going to be created in generation 0 object, right? Now let's build the solution. Yeah, build succeeded. Now I need to run the application, profile application. You need to select the exe. Exe I have selected, and I just need to click the start button. Once I click the start button, then you will see that the exe will run. That means our application is run. You can see this exe is run, and you can see all the objects are created inside the generation 0 only. So generation 0 means you will get better performance. If you are having object in 1 and 2, you will get your performance will be down, right? And when you will get the object in generation 1 and 2, when you are creating destructor in your class, and when one object is going to be stay in the memory for a longer period of time. Suppose you are creating one object and you are not making that object null, or you are not using that using statement to creating the object, right? And if you want that object is created from the beginning, and you want that object to be destroyed at the end of your method call, right? And then in that case, it will be going to be in your generation 1 and generation 2 buckets, right? Is that clear how exactly the garbage collector implemented in .NET framework? What are the different generations? When you create a fresh object, in which generation the object is going to be created, how the garbage collector will move the objects from one generation to another generation, how the destructor is bad from performance point of view, and how we can overcome the destructor performance issue by using the dispose design pattern. Is that clear?
So one question here, like if the dispose function is overwriting the destructor, then what is the use of destructor? Is it used in a real-time application?
Yes. Suppose you are creating this construct, this object, and from your application you forgot to call this dispose method, right? And it's a unmanaged resource. Think that it's a unmanaged resource, and after using that unmanaged resource, you call this a dispose method, so that the unmanaged resource is going to be deleted from your application, right? But you forgot to call this method. Then how the unmanaged resource is going to be executed? There is a destructor, right? In that scenario, the destructor is going to be executed, and that destructor is going to destroy the unmanaged resource. That means destructor will act as a backup. So in this case, you forgot to call this dispose method. That means this statement is not going to be executed. This statement not going to be executed means we are not informing the garbage collector to ignore the destructor, right? That means whenever the garbage collector check is there any destructor, then it will ask that destructor to execute, right? The destructor will act as a backup for your dispose pattern, right? If you forget to call the dispose method, then destructor is there to destroy the object. Is that clear?
This destructor is not default, right? We have to declare in each and every class where we need to use it, or will it be called by default?
See, no. So two things is there. The destructor is going to be invoked by default, right? It is going to be invoked by the garbage collector only. If your class having any destructor, then garbage collector will ask, do you have any destructor? If yes, then garbage collector will invoke that destructor, right? Now if your class is a unmanaged resource, suppose your class having some unmanaged resource, if you are not implementing this destructor and you are not calling this dispose pattern, then how that unmanaged resource is going to be deleted? Garbage collector will not have the capability to delete the unmanaged resources now. If your class having some managed resources, if you implement this dispose method or if you are implement this destructor or not, that doesn't matter. Managed resource, garbage collector will destroy. But if your class having some unmanaged resource, then garbage collector will not delete now. Then in that case, you need to write the unmanaged code resource release logic inside the destructor or inside the dispose pattern. If you are writing dispose pattern, then it will ignore the destructor. If it will ignore the destructor, then you will get better performance, right? But if you forget to call this method, right, then the destructor is there now who is going to execute, and that destructor is going to be called automatically by the garbage collector, and that destructor is going to destroy the unmanaged resources. But if you have not written this destructor, and even if you have not written this dispose method, then the unmanaged resource which you created for your application is never going to be released. And at the end, what problem you will face? Memory leakage issue.